Hello, hello. Please confirm if you do hear me. Hello? Hello? Please confirm if you hear me. Excellent. Did you hear me before? Okay. I was watching and listening for you. Angela, can you make sure that my screen will be projected on a big projector? I'm doing content sharing. Okay. Is it everyone can see my screen? Yes? Okay, good. If you need to support discussion, please inform me by voice. When I do show slides, I am missing video feedback and I do not see if you wave hand, agree or disagree. So today's meeting will be short and quick. The end of the course is very soon, and maybe some of you are worrying about written reports and oral presentations, as well as completion of the research projects. Let me share the schedule and give comments on troubleshooting the computational research, analyzing and assembling data into figures, and writing written reports. It looks like we do have 4 meetings to complete. I believe you do see my mouse circling around these dates. Today, coming Thursday. Okay, good. If there will be a gap, I will stick in additional method of configuration interaction, just for curiosity, but not today, maybe on Thursday. Main goal is to complete mini research, write written reports, and complete presentations. On coming Wednesday, tomorrow, I will be in the airplane, but postdoc Yulun, Dr. Han, and graduate student Aaron Fordy will come to the Wednesday night lab and help everyone who needs help. Last lab on Wednesday, I will be there, and those who will have last-minute problems for videos, for presentations, will also troubleshoot and make sure everything works. Ideally, by tomorrow night, all your calculations should be complete. It's not always possible. On coming Thursday, in 2 days from now, I will focus on combining your research data into written report, into mini paper. In 1 week from now, we will do reviewing session. So it is expected that everyone will bring a draft of the written report to the to the class. 3 printed copies. And we will practice reviews. On the night of the same day, I am expecting electronic forms of the very final versions of the written reports. And on next, not tomorrow, but in a Wednesday next week, midnight, I am expecting PowerPoints of your final presentations on research projects. Whatever we can complete until then, let's do it. So here are the projects that you have selected. And we do analyze models before and after molecular dynamics and compare this electronic characterization properties. Not everything is possible to complete. This table is just a guide for summary of what one can do for characterization of the models. So let me briefly comment on expected format of results, expected format of figures, and answer questions on troubleshooting for computations. We will do it today, tomorrow with Dr. Yulun Han and Aaron Fordy, and on coming Thursday. I believe I have sent a couple of examples of papers that were developed based on the successful in-class projects. Please confirm orally if you got something like that. Only Vijay? No one else? Okay. Okay. Good, good, good. You're not expected to read everything. Your tight and busy schedule doesn't allow it. Typically, one just scrolls through and looks for pictures. If they catch eye, one can focus on a couple of paragraphs. So the first attachment is the paper by Jinchao Chen, and it is first paper made as part of this class, and it was very successful, and it was following the general ideas of comparing different electronic configurations, electronic structure before and after thermal treatment. So here is one of the figures from this paper, and you do see that electronic structure represented as density of states experiences modification due to charging, excitation, adding impurities, or in the panel E, thermal treatment. Well, thermal treatment closes the gap and screws up everything, but it is interesting observation. There are two categories of papers in the past and two categories of research right now. Charge transfer at interfaces and reaction dynamics. Whatever category your research belongs to, you may get inspired from looking on examples, and I will be happy to provide more examples if needed, although it is much more interesting, pleasant, and inspiring to do your own research rather than read what others are doing. So the charge transfer interfaces, or just hybrids, composites of component A plus B, includes research by London, Vijay, and Daniel Ramirez. And the catalysis and reaction includes projects by Christian, Russell, Braden, and Alyssa. And Daniel and Alyssa are on border between first and second categories. So some of you are already successful sharks in the ocean of academic research and publishing. But for some of you, it is a first experience of research and writing research reports. Or maybe you are in between. So just in case, to avoid or answer ahead possible questions that you may ask about organizing your research results, I would like to give some comments. Again, maybe you have already developed an image and plan how to process with your project, and I do not want to affect and contaminate your plan. These comments are needed only if you have doubts what to do and what not to do. So I will share brief comments on how to organize research data, what to do, what not to do if your research is not yet complete, what to include, what not to include. So it is a very rough sketch of the logic, and it is generalized to match all of the projects. So it is not literally coinciding with everyone's project. I'm going to say something, but no one in the class needs to follow it literally. It is just an ideas developed an understanding that complete list of suggested research steps cannot be completed in a given time. Okay, so there are three large logical sections. One, initial assessment of the equilibrium geometry. Do you see my mouse circling? Please confirm. Okay, thanks. Otherwise, I would need to tell, like, look at the upper right or whatever. Okay, middle section is running molecular dynamics, and the last one is assessment of the geometry that has been perturbed by interaction with lattice vibrations or with motion of ions. So I'm going to give brief comments on each of these three chapters, logical blocks. So first block, initial assessment of geometry. It is slightly different in case you have a standalone one compound or you have hybrid composed of two heterogeneous species. Generally, if your compound doesn't have structure, you do geometry optimization, and it is reasonable to watch movie of optimization as it develops to avoid running of optimization in the wrong direction. And then upon optimization, or if optimization is not possible, just single point of what you have prepared as geometry, you assess total energy, gap, whatever, ionization if needed, draw density of states, spectra, orbitals, and if it is needed, if it is justified for your systems, you can repeat it for anions, cations, excited, singlet, triplet, doublet, as time allows. Okay. Now, if your model is a hybrid, is a composite of two heterogeneous species, molecule and solid substrate, two molecules, two solid nanostructures, what can you do? What is reasonable to do to analyze this system? So first, to assess binding energy as comparison of total energy of the hybrid composed system minus total energy of species A and species B. Second, one can compare if the density of states, if the electronic structure of a hybrid composite system can be approximately represented as density of states of compound A and compound B. It is not always so. If the species are non-interacting, then it is literally equal. But if they're placed together, or if there is a chemical bond formed between them, there are substantial changes that species A and species B exert on each other. Same analysis can be done for absorption spectrum. If species are non-interacting, then absorption spectrum of species A and absorption spectrum of species B added together will give absorption spectrum of the hybrid, of the composed system. But if they are interacting, if there are charge transfer excitations when upon photoexcitation charge carriers migrate from one species to another one, then this will be not an equality. It will be something more complicated. And another way to characterize hybrid system composed of heterogeneous compounds is to analyze orbitals. It is extremely intuitive and helpful. So first, one may look into the file with oscillator strengths and identify pairs of occupied and unoccupied orbitals that provide largest oscillator strengths. Not all of them, just a couple. You will become acquainted with the system, with its property. Then one can look onto the orbitals and identify for orbitals in the vicinity of the gap whether a given orbital belongs to species A, belongs to species B, or is hybridized between both of them. If there is no chemical bond, if they interact weakly, then most of orbitals will be localized either on A or on B. Then one can look onto the pairs of orbitals representing excited states and look what is the character of an excited state composed of pair of orbitals. So one can observe that there are possibilities for localized excitations on species A when both occupied and unoccupied orbitals belong to species A. There could be an excitation localized on species B when both occupied and unoccupied orbitals belong to species B. And there could be charge transfer excitation when occupied is on A and unoccupied is on B, or otherwise. If you want to assess ability of your material to emit light or facilitate formation of charge transfer state for photovoltaics, this analysis is most critical. Charge transfer states do not emit. After I will complete this brief review, I will bring back the camera and I will see if you wave hands and ask questions. Okay, done with initial assessment of equilibrium geometry. Now, molecular dynamics and thermal treatment. It can be done in two ways. The simplest way is to, well, in both ways. Molecular dynamics is split on two parts. First, preparation of initial conditions, and second, running actual molecular dynamics. So in first way, the preparation of initial condition is corresponds to assigning random velocities to all atoms by existing VASP procedure. corresponding to a given temperature. As a master of your research, you select which temperature you want. Of course, it would be very interesting to rerun dynamics at different values of temperatures. 1 Kelvin, 2 Kelvin, 3 Kelvin, 100 Kelvin, 1000 Kelvin, 10,000 Kelvin. But it is expensive. It's not always possible, especially in our tight time limits. So it is your scientific intuition which temperature, or maybe a couple of temperatures, to choose. Based on your intuition, you may want to select temperature which will be a little higher than activation energy for reaction, if you expect a reaction. Or if you do not expect reaction, melting, evaporation, you can just go with room temperature. Or if you are impatient and you want to speed up dynamics, you can elevate it a little compared to room temperature. So there are no rules. Here is your scientific intuition and creativity. One of the class attendees did ask an excellent question a couple of days ago. Is there a criterion for completion of molecular dynamics? The answer is no. There is no mechanistic criterion. As soon as you pump kinetic energy to nucleus, it will last forever. If you have damping procedure and your physical system dissipates energy into environment, it will be just random thermal motion, but it will never equilibrate. So there is no end for molecular dynamics. So we decide as humans creatively when to stop it. And computational facilities dictates us how long can we run it. If you have unlimited resources and you want to decide how long to run it, you may want to run it until desired reaction or phase transformation or thermal motion induced event happens. So you just watch dynamics as it occurs, and as soon as you see that it happened, you stop it, or you anticipate how long should it take until it happened. For example, if you do collisions in the next subchapter, you just look for double of the time that reactants need to arrive to catalyst. So it arrives, bumps, and then desorbs about half of the time period for each. If reaction happens, you will see it. If not, there is no reason for further running of the molecular dynamics. I hope the person who asked this question is satisfied now. And if there are more questions, very soon we will come to discussion regime for asking and answering questions. Second way to arrange reaction dynamics or molecular dynamics. Again, two steps: preparing initial conditions and actual molecular dynamics. If you are modeling gas phase or liquid, at least for a part of your model, if there is an adsorption, desorption events, then you may already have you may have observed that awaiting for collisions of molecules takes a lot of time. especially if they have random velocities of random values and random directions. Eventually, everything will collide, but it may take much longer than we have patience. So we can make an approximation that we finally observed random collision when the colliding species are targeting each other. And instead of waiting infinitely or very long time, we can set up the collision conditions. How? Suppose you have species A and species B with center of mass, or most easily if it is a single atom, species A and species B. You connect them by a vector with components delta x, delta y, and delta z. Then you can freeze species A and give initial momentum to species B collinear with vector that connects their centers of mass. So momenta projections on x, y, and z will relate to each other in the same proportion as components of the vector connecting centers of mass. So you have delta x, delta y, delta z, and multiply by a factor that will determine how quick they bump into each other. Don't forget to put minus sign. Take care so that they approach rather than depart. There is a little alternative. If computing these projections makes you bored, one can rotate the whole model to such angle that species B will be literally above species A. So they will lie on the z-axis. Then you can keep projections of momentum on x and y equals 0, and projection on the z-axis equal to overall momentum that you want to assign to this colliding species. There is an additional technical challenge: how to find right atoms in the WASP input file. Since they are not labeled at each line, you need to count lines and decide that atom number 60 is oxygen from water. Atom number 151 is first hydrogen, and atom number 166 is second hydrogen belonging to the water. It is a pain. There are some ways to simplify it, but it is most painful procedure. Let me know if help is needed to mitigate it. And as soon as you have prepared initial conditions, you run molecular dynamics and watch how the outcome of the molecular dynamics depend on the initial condition. In this situation, it makes sense to run it more than once with different values of initial momentum and maybe slightly different angles, so that projectile slightly miss the target. It may activate additional reaction channels. Done with molecular dynamics. So upon the molecular dynamics is done, you can do final assessment of electronic properties of your model in the geometry that resulted from molecular dynamics. So it will be geometry far from equilibrium. Therefore, electronic structure will be far from the one you found at step 1. And here you can look at geometry, look at total energy, look at value of the gap. It will be expected that the gap will be substantially reduced due to thermal motion, especially if the temperature is much above room temperature and if there were chemical reactions, adsorption or desorption events. Gap, binding energies, and density of states may change drastically. Same about spectra. Orbitals, if you have time and steam and energy to plot them, will likely change upon thermal motion. For example, if you have ground state periodic crystal or conjugated polymer, something that repeating units are all equal to each other, then orbitals in periodic system, especially frontier orbitals, are delocalized over all atoms of such homogeneous system. But if system experiences thermal motion, it loses symmetry and forms defects. And then orbitals will be localized on such defects. Maybe no one of us will have time to make this little exercise, but if you do, you will likely observe this trend. So perturbation of geometry by thermal motion creates defects and induces localization of charge density and orbitals. What else? One can look at temperature as function of time. If your system is big and if there are no reaction, temperature should stay around average value. But if there are chemical reactions releasing heat, then the proportions of kinetic and potential energy may change, and you may see change in temperature and in kinetic energy as an evidence of chemical reaction. Another characterization is monitoring of energies of individual orbitals as function of time. But it's probably too much for this project. Let me exit the presentation mode and enter the discussion mode. Okay, so questions. I didn't hear. I will follow your question much better if I see you. And now I am projecting video of the class to my screen. Oh, GREP space apostrophe T capital equals apostrophe space Ozicar, OSZICAR. So at each time step of molecular dynamics, there is a record of temperature, kinetic, and potential energy. And this parsing with grep allows to get it. And then you can put symbol bigger and forward this information into a file. You can call the file like TT. And then plot content of this file with GNU plot or your favorite plotting software. Any other questions? So everyone is happy. Oh, let me ask the question. Who believes that he or she has completed more than 50% of computations needed for this project compared to original plans? Okay. Who thinks that he or she completed less than 50% of what is needed? Okay. Okay. So is it because your schedule is super busy, or there were technical problems with clusters, with facilities? Please raise hands if you blame facilities. Okay. Okay. Please raise hands if your schedule is just too busy. Uh, okay, but is it? Please confirm that you can make any job to go through. That you do not have panicking situation when you need to run a job and it doesn't run. Okay, raise hands if any of you has a panicking situation when you need to run a job and it doesn't respond to any of your efforts. Okay. So only Vijay with large system. So it is probably the consequence of the size of the system. Please increase number of nodes and number of cores and check if it will work. And share with me the link. I am very curious to look at, and as time allows, I will try to. So please do not hesitate to submit more jobs than needed, to arrange a competition between your jobs so that the same job is submitted at different facilities so that it will be complete for sure. What else I wanted to ask? Initial parameters for characterization. Does anyone need help with plotting or post-processing or generating files for orbitals? No one. Okay, I'm double checking. Please raise hands if you are confident in your skills of plotting, of generating and plotting orbitals for your system. Okay, good. So Russell is not here, but Braden and Alyssa are here. Can you briefly tell how do you plan to analyze development of the reaction? Do you have any ideas or any problems that you realize? Let me bring up more common. Suppose you have completed dynamics that show reactions that you like and that you need. How would you communicate it to the class and to the reader of a paper? Especially if you cannot show the movie. Okay, plotting snapshots along the trajectory. Yes, it is an excellent idea. There is an alternative way to represent the reaction that you may not practice, you may not need it immediately, but it's better if you keep it in mind as an opportunity. One may realize that your reaction of choice corresponds to increase of interatomic distance between atom C and D and increase of interatomic distance between atom D and H. So one may plot interatomic distance between selected atom as function of time. Abrupt elongation or abrupt contraction of interatomic distances is a clear evidence of a reaction. Just keep it in mind if you realize that you need like 100 snapshots and you do not have enough space to show it. Okay. Anything else you want me to cover? No one needs anything. It is just an option how to analyze your results in a better way. So the system that Alyssa is doing is super huge. It is a champion system, 10 times bigger than anyone else is doing in the class. And it will have huge amount of orbitals that you may not have time to show and even to look and analyze. Maybe only HOMO and LUMO and only once, or maybe after completion of reaction. What one can do is to plot total charge density that is located in the file
CHG, that stands for charge. And it will reflect any drastic changes in the electronic structure. Of course, it is less detailed information than orbitals. But if the system is truly huge, maybe nothing else is possible. Make sense? Good. And London especially, and Vijay maybe, and Daniel maybe, may want to learn how to generate file named locpot, LOCPOT. This file has the same format as orbitals and as total charge. And this file should be very near and dear to the heart of London. Integrating such file over X and Y will give one-dimensional potential for MATLAB simulation if anyone has curiosity to do so. Okay, I am going to announce completion of our meeting. Let me ask once again for any questions. Any questions 1? Any questions 2? Any questions 3? Okay, I'm crossing hands and showing them to tell that the meeting is done and we are going offline. There will be, so now announcement not to the whole group, but to those who visit group meetings on Tuesday. There will be one today. If you want to get feedback to introduction section of your big life research papers, you have the opportunity to bring and get this feedback, but please do not forget to print it. Since some group members are on the travel, there could be delays with centralized printing. So if you are coming to the meeting at 4, there will be enough people to read and provide feedback, but there is no guarantee that there will be centralized printing. Okay, thank you much. Looking forward to see you on Thursday, and the Aaron and Yulun will take care of the meetings today's afternoon and Wednesday night. I'm changing emails regularly and will try any opportunity to contribute to completion of your project. Okay, going online, offline. Bye-bye. Bye.